Here we're going to look at the absorptive and post-absorptive states. These are what happen when you eat and between meals. This ties in a lot with chapter 17. When we learned about hormones, you learned about insulin and glucagon and how they regulate your blood nutrients. This is going to be about insulin and glucagon and blood nutrients. So we'll start off with the absorptive state. Absorptive state is what happens when you eat. When you eat, your intestine puts nutrients into your blood. So we have nutrients going from the blood, and remember you have three basic types of nutrients. We're going to have glucose, amino acids, and lipids. So you digest carbohydrates into glucose, you digest proteins into amino acids, and you digest your lipids into, it's going to be mainly triglycerides. And with the lipids, they go through the lymph first. Remember, they're picked up by lacteals, but then lymph goes into the blood. So they do end up in your blood. So during this time, you have a rise in blood nutrient levels. Now remember, you always want to maintain homeostasis. So you don't want your blood nutrient levels to be too high. So your pancreas, you can see it tucked back here behind the stomach. It monitors your blood glucose. It's not monitoring so much the amino acids and triglycerides, but it just assumes that if glucose is high, the other nutrients are high also. But glucose is the one that your pancreas responds to. So in this situation, when blood glucose is high, the pancreas secretes insulin. So now we have insulin from the pancreas going into the blood also. The job of insulin is to reduce the blood level of nutrients. So you're going to move nutrients out of the blood and into other tissues. So we have glucose is going to go in the liver and be stored as glycogen. And if you remember those terms from chapter 17, this is going to be glycogenesis, formation of glycogen. You're also going to do that in your muscles. So you will get glycogen in your skeletal muscles, also through glycogenesis. The amino acids will go into your muscles where you will do protein anabolism. So you will build the amino acids into protein, and you will also do that in your cells. So this last picture here just represents cells in general in the body. The cells in general will also take glucose in response to insulin, and they are going to use the glucose to make ATP. Then we have the triglycerides are going to go here to your adipose. So that's a picture of some adipocytes. And you're going to do lipogenesis. And you're going to store the triglycerides as adipose. You're going to add to your body fat. So now that the nutrients have moved out of the blood, the result is reduced blood nutrients. And you have an increase in storage, so you have your glucose and your lipids are stored. You also have an increase in cells using glucose to make ATP. And you have an increase in the amount of protein in your body because you did protein anabolism. So this is what happens when you eat, this absorptive state. Now let's look at the post-absorptive state. This is between meals. Your small intestine is no longer sending nutrients to the blood. So there's nothing here. That's all done. So that means that your blood nutrient levels start to fall. So remember, homeostasis. You want to maintain those nutrient levels. So now your pancreas is again going to respond. The pancreas will respond to the drop in glucose. And it secretes glucagon. So now you're going to put glucagon in your blood. And the job of glucagon is to raise blood nutrients by moving the nutrients out of tissues and into the blood. So your liver has the glucose. We're going to return that to the blood. So you're going to do glycogenolysis. So remember, lysis means break. So this is where you will break the glycogen and return the resulting glucose to the blood. So glycogen is just a bunch of glucose stored together. So when you break the glycogen, then you're back to having a bunch of individual glucose. And here with the adipose, we're going to return triglyceride to the blood. And that is lipolysis. So this is where lysis break, you're going to break your adipose and return the resulting triglyceride to the blood. So notice that glucagon reverses only 2 of the things that insulin did. There's other things that glucagon does not do. Glucagon, let's make a heading here. It does not, so we'll list the things glucagon does not do and why it doesn't do them. It does not return glucose from the muscles. That's because the muscles will use that glucose. It also does not return glucose from your cells. Because remember, the cells used that glucose to make ATP. That glucose is now converted to carbon dioxide and water. They can't return it. So think back to chapter 3 when we learned about cellular respiration. When you break down glucose, it ends up combining with the oxygen that you inhale to become carbon dioxide and water. We also do not return any amino acids to the blood. It's because these amino acids are now part of the proteins of your body. And your body doesn't like to break down its proteins. You don't want to sacrifice these proteins you've built. Okay, so there's everything glucagon does and doesn't do. So between these two states, all the time, you're either eating and you're an absorptive, or you're between meals and you're post-absorptive. So your pancreas, with its insulin and glucagon, keeps you in balance of your blood nutrients all the time. Cholesterol is an important nutrient in your body. It gets a bad reputation. A lot of people think of cholesterol as clogging your arteries, but it's only bad if you get too much. You couldn't live without cholesterol. You have to have it to stay alive. A few examples of things cholesterol does in your body. It's part of your cell membrane. So remember, the membrane is made of phospholipids, but the cholesterol is in there mixed in with the phospholipids to help stabilize it. So if it were just the phospholipids on their own, the membrane would be really runny, and the cholesterol kind of firms it up and stabilizes the membrane. Remember back in chapter 6 when we learned about the skin makes vitamin D? And it's because it converts cholesterol to vitamin D. So if you didn't have any cholesterol, there'd be nothing for your skin to convert to vitamin D, and you would become deficient in vitamin D. And if you think back to chapter 17, cholesterol is what all of your steroid hormones are made from. So, for example, the sex hormones, estrogen, testosterone, the adrenal cortex hormones, and one that we've talked about a few times this semester is aldosterone. There's several adrenal cortex hormones. Aldosterone's the one we've covered. So those are some of the reasons why you need cholesterol in your body. Your liver is in charge of cholesterol. So your liver distributes cholesterol out to your body. It's kind of the organ that's in charge of passing out the cholesterol to all the other parts of your body. It also collects cholesterol back from the body. And it does this to maintain a balance. So your liver keeps you at your set point for how much cholesterol your body should have. So you have a genetic set point. And your liver keeps you at your set point. By passing out cholesterol and taking it back. Your liver can also make cholesterol. So if your diet doesn't have enough cholesterol in it, that's okay. Your liver can make cholesterol for you. And your liver is the organ that can get rid of cholesterol from your body. Okay, then a note about the nature of cholesterol. Cholesterol is a lipid. And we know that lipids do not like water. Lipids are hydrophobic. So cholesterol is not going to mix with water, but your blood is mostly water. So whenever cholesterol is traveling in your blood, it has to be packaged in a protein. And your liver makes these packages for the cholesterol. Now we're going to talk about density. If something is low density, it will float in water. If something is high density, it will sink in water. So density is how tightly packed the molecules are. So when we talk about the density of something, we're talking about how tightly packed the molecules are. Higher density means that the molecules are more tightly packed. Lipids are low density. Think about when you mix oil and water, the oil floats on top. Proteins are high density. So this density is how we name the packages of cholesterol. Let's start looking at the picture now and labeling some things in here. So this is a liver cell. Okay, all the blue and green things with the yellow in the middle, those are the packages of cholesterol. We're going to start off, if you look at this one, it's a yellow dot with a thin blue line around it. So let's come down here and redraw that so we can talk about it. So we have this yellow dot, and I'm using orange because yellow doesn't show up very well when I write in that. And it has this thin blue line around it. The name of this one is VLDL, which stands for very low density lipoprotein. The blue line is the protein package. And the yellow dot is the cholesterol and some other lipids. They're kind of mixed in there together. So remember, lipids are low density, protein is high density. This VLDL is mostly low density lipid. It only has a thin protein coat. So since it's mostly low density lipid with just a little bit of high density protein, it's classified as a very low density. Let's look at our next one. If you look here, this one is an LDL. It's that same thin protein coat, but only half the lipid. So we have that same thin protein coat. But now it's only partially filled with lipid. So when you look at the ratio of lipid to protein, there's a little less lipid now. So that's why we drop the very low density. Now it's just low density because there's still more lipid than protein. But not as much lipid. So that's why we drop the very. There's one more to look at, and that's the green one. The green one is HDL. And notice in one of them it's empty, and the other one it has a little bit of cholesterol in it. Either way, it's still called HDL. And if you look at this, the green is the protein coat. Notice how it's a really thick protein coat compared to that blue thin protein coat. So the HDL is a really thick protein coat. With just a little drop of lipid in the middle. So now that you have mostly protein and just a little bit of lipid, this is more of the high density. So you have more high density protein than you do low density lipid. So this is high density. be any cell because they need it for their membrane. It could be a skin cell that will use the cholesterol to make vitamin D. It could be an ovary cell that will use it to make estrogen. It could be a testes cell that will use it to make testosterone. It could be the adrenal cortex that will use it to make aldosterone or another adrenal cortex hormone. This is not a complete list. There's lots of other uses of cholesterol. This is just to give you a few examples of what's going to happen with that cholesterol. So that's the process of distributing cholesterol out to the body. So LDLs are what take cholesterol out to the body. So these two in our blue here are what deliver cholesterol out to your body parts. Okay, now let's look at what the HDL does. So we start off, here is step 1. In step 1, your liver makes an empty HDL. So notice there's no cholesterol there in it, no yellow dot. Then here's step 2. You send that empty HDL into the blood. Then step 3, it picks up cholesterol from a body part. Then here is step 4. It comes back to the liver. So a full HDL returns to the liver. So that's how your liver gets cholesterol back from the body, is in the HDL. And when people are measuring cholesterol, having it checked to see their risk of heart disease and so on, they tend to refer to LDL as the lousy cholesterol. That's how people remember it. And HDL is the good cholesterol. You can have different ratios of these. So if you get your cholesterol checked, they can check your ratio of HDL to LDL. And if you have a high LDL and a low HDL, that means you're sending out more cholesterol than you're getting back. And so you have this buildup of cholesterol out in the body. And when you get that buildup of cholesterol, that's when it can start to clog your arteries. Okay, one last thing to talk about now, and that's how you actually get cholesterol out of the body. So in some cases, it's going to exit with its product. For example, your cells are always dying and falling off, right? We've talked about dust as your dead skin cells, and they all have cholesterol in their cell membrane. So there's just going to be like normal losses as cells die. When you make hormones out of cholesterol, hormones end up being lost in your urine. So you're going to have like hormone losses from that were made from cholesterol. So there's just kind of the using it. Then there's also how you can really, if your liver wants to get rid of cholesterol, the main way you get rid of cholesterol is when your liver puts it in bile. And then, as you know from chapter 26, bile goes to your small intestine. and it emulsifies the fats so that you can digest them. Then your nutrients are absorbed into your blood and your lymph. During this absorption process, 90% of the cholesterol in the bile is absorbed with the nutrients. But 10% is not. That other 10% remains in the intestine and then leaves the body with the feces. So that's how you can get rid of cholesterol you don't want. Just put it in the bile, send it to the intestine, but then 90% you'll get back, but 10% you can get rid of in the feces. So there's some basics of cholesterol. There's a lot more if you study more deeply about cholesterol, but this is just kind of an overview of the main ideas. Well, you've learned cellular respiration twice before. You were first introduced to it in Chapter 3, then again in Chapter 10 when we learned about muscles. Now we're going to take more of a big picture look at cellular respiration. If we kind of do an overview of the basics, we know that it starts with glucose, which is C6H12O6. Now, you can also use amino acids and fatty acids. But we're not going to worry about going through all the chemistry of those processes. We're just going to focus on glucose. So if we look at our glucose, we know that we're going to take the hydrogen out. You use hydrogen to make ATP on the electron transport chain. So the main idea is to get that hydrogen extracted out. And that's what you do in the first two steps. So the main thing that's happening in glycolysis and Krebs is you are breaking the glucose so that you can get at the hydrogen and send it to the electron transport chain. And that's where you get the majority of your ATP. And remember, the hydrogen will basically push the ADP and the P together so that you get ATP. So remember, ADP is adenosine diphosphate, and then you add that extra P onto it, and you have adenosine triphosphate. Once you get the hydrogen out, you are left with 6 carbons and 6 oxygens because it's C6H12O6. So you take the 12 hydrogens out you have 6 carbon and 6 oxygen left. These are waste. So you have to take in six molecules of oxygen, and this is what your lungs get from the air. Then you will have 6 carbons from the glucose, 6 oxygens from the glucose. And you will have 12 oxygens from the air, and you have your 12 hydrogens after they go through the electron transport chain. All of this now gets made into 6 carbon dioxides and 6 waters. So you take your 6 carbon, your 6 oxygen from the glucose, you take 6 of these oxygens, I'm sorry, there's not a 2 there. It's just 12 oxygens because 6 times 2 is 12. And this is what gives you your 6 CO2. And then you take the other 6 oxygens and your 12 hydrogens, and that is what gives you your 6 water. So if we look at this in kind of more of a big picture, you're going to eat glucose. So we have glucose is C6H12O6. This is in your food, so you eat this. You also inhale oxygen. So now you have glucose and you have oxygen that have gone into you. All you do is break down the glucose, you break up that oxygen, and you rearrange it into 2 new things. So you're going to end up with 6 carbon dioxide. That 6 carbon dioxides are going to have 1 carbon and 1 oxygen from the glucose and 1 oxygen from the oxygen that you inhaled. Then you also get 6 water. The hydrogens in the water are from the glucose, and the oxygen in the water is from the oxygen that you inhaled. So these are what come back out. So you eat food and you get glucose, you breathe and you get oxygen, then you rearrange those molecules, you exhale carbon dioxide, and you urinate water. So what goes in comes out. You just rearrange in between. So you have glucose and oxygen go in. You rearrange them into carbon dioxide and water. Your payment for doing this rearrangement is 36 ATP and body heat. So this is kind of what's commonly referred to as your metabolic rate, how fast you do this. And there's a couple of ways to measure metabolic rate. think about this carefully. You have things going in, you have things coming out. Two of the main ways to measure metabolic rate are to measure the oxygen that goes in, and then remember your payment is 36 ATP, and body heat to measure the heat you produce. So one way to measure metabolic rate is they put you in a tub of water. And your body heat will make the water warm up. They can measure how much you warm up the water and use that to calculate how much cellular respiration you're doing. The other common way to measure metabolic rate is oxygen consumption. So you can go into a sealed room. That way they know how much oxygen was in that room when you entered, and they can measure how much oxygen is in that room when you're done. So they measure the oxygen, they put you in the room, and they measure how much oxygen you take out of the air. Because every time you do cellular respiration, you're using 6 oxygens. So they can calculate how many oxygens you took out of the air and then know how much cellular respiration you did. All right, so there you go. There's the basics of how you get ATP and body heat and how you can measure that.